Good day. We are looking at something called molar volume. This applies to gases, and hopefully you're getting used to things. Molar mass means the mass of 1 mole of particles. Molar volume means the volume of 1 mole of gas under certain conditions. The certain conditions typically are going to be temperature and pressure, both of which can affect the volume of gas greatly. So there's our definition. Sorry if the colors are terrible. The volume of 1 mole of gas under certain conditions of temperature and pressure. We know increasing the temperature makes the volume bigger, and increasing the pressure of a gas makes it smaller. Avogadro. We had Avogadro's number from earlier, the value of the mole, and he had a hypothesis. Equal volumes of gases under the same conditions of temperature and pressure will contain the same number of particles. What that's saying in English is, it doesn't matter about the identity of the gases. The gas could be chlorine, fluorine, helium, carbon dioxide. If you put them under the same conditions and you have the same number of moles or particles, they'll occupy the same volume. That's what independent gases identity means. We've talked about how a gas is affected by it. Increasing temperature increases the volume of gas. Increasing the pressure decreases the volume of gas. Now we have something called STP. And the old days of Chemistry 11, we used to do a chapter on gases. We typically don't have time for it. In Chemistry 12, we do a Reader's Digest version on gases. Well, standard temperature and pressure, that's what the STP stands for. So chemists or physicists decide that standard temperature would be 0 degrees Celsius. Standard pressure would be 1 atmosphere pressure. Well, standard temperature is also known as 273 degrees Kelvin. And for any calculations, if we went on and did this, our temperature has to be in Kelvin. Because we can't end up with negative volumes, we can't have negative temperatures like Celsius would allow. It turns out that 1 atmosphere of pressure is the same as 101.325 kilopascals. Another unit of pressure, just for interest, is millibars. You'll see it often in weather. And so this would actually be 1013.25 millibars. But all you care about is atmospheres and kilopascals, that those two numbers are equivalent pressures. After careful calculation, it turns out that STP, molar volume, is 22.4 liters per mole. Doesn't matter what gas it is. At STP, 1 mole of gas will be 22.4 liters. Well, if there's STP, it turns out there's RTP. And the only difference is, instead of 0 degrees, R stands for room temperature and pressure. And so chemists and physicists have decided that room temperature is 25 degrees Celsius. You might disagree based on the science room. Anyways, 25 degrees is 298 Kelvin, and the standard pressure stays the same as before. We're at a higher temperature, so the volume expands slightly. 24.5 liters per mole. For years, you may have been looking at the box hanging from the ceiling near the whiteboard, and it says something like molar volume or the mole on it. And what that's saying is that's actually 24.5 liter box. And so that's saying there would be a mole of particles there if we're at 1 atmosphere and if we're at 298 Kelvin. Well, how do we use these things? If we're going moles to volume, we take our moles and we multiply by 22.4 liters per mole if we're at STP, or we multiply our moles by 24.5 liters per mole if we're at RTP. And obviously, if we're going from volume to moles, we undo what we did. And that means instead of multiplying, we divide. So these are the kind of calculations, simple calculations you're going to use based on the conversion factor at STP of 22.4 liters per mole or RTP 24.5 liters per mole. And you also will be provided a slightly more exotic conversions chart. Not that you're allowed to use on tests, you're allowed to use it when you're practicing, but it's something you will have to memorize. Our next video, we're going to look at calculations involving molar volumes, and after that, then we'll look at the deluxe conversion chart.